Hello and welcome to the final presentation for CIT260, Object-Oriented Programming. My name is Rob Wagner. I'd like to thank Brother DeBry and my teammates, Cam Cook and Kathleen Nelson, for all that they've contributed to the learning process. We'll go ahead and get started. Forgive me if I don't sound 100% jovial like I usually like to. I woke up this morning with the flu, or worst possible timing, so hopefully this will make sense and it will have a minimal impact on the presentation. Let's just go ahead and do an overview. We're going to review some of the components that we've learned in object-oriented programming, and we used Java as our vehicle for this class, so everything that we review is going to be based in Java. We'll demonstrate the functions in a live project demo, as well as share some images of different code that was used to achieve the objectives of the class. This project is closely based on the text-based role-playing game Hammurabi, which can be found at www.classicreload.com/hammurabi.html. For a game that was introduced several years ago, it's surprisingly enjoyable to play. It's just a matter of executing strategy and understanding the math. However, in our game, this really takes place in the ancient times of Joseph in Egypt, before the years of famine. You will play the role in this game of an overseer for Joseph's one of his villages, and will be responsible for managing resources so as to not lose any of the population. So first thing we're going to do is we'll just go ahead and jump into classes and variables. So in object-oriented programming, each program is made up of classes, and each class is made up of variables and functions that relate to it. So there are two primary types of classes or variables. There's static and there's non-static. In the static, this is when you want something to stay the same. It is set as static. This means that the characteristics and attributes associated with that class or variable remain the same. For example, in our program, the map class is static because the value does not change whether you lose people or whether you gain more wheat. The map is always going to be the same. Non-static is when you have an instance variable, or a variable or function may change depending on user input. So an example of this is maybe the amount of grain that you have. Could be a non-static example because as you increase in grain or as you decrease as you buy land, that might change. So here's an example of a static function. So public static void display map. Now, when you look at the map, there's going to be, so the 1, 2, 3, 4, 5 here is just part of the grid. This is a 5x5 map, and then they'll have different symbols that represent the map itself. So as you look at the map, that part's not going to change, so therefore it's a static example. Now let's go ahead and take a look at arrays, array lists, and enums. First, let's look at the different types of lists. So an array is static in size, so the number of elements within an array does not change once the object is created. When referring to a list of fixed elements, such as an array matrix, representing different sections of the map, which we'll look at in just a second, the map neither grows nor shrinks. The array option may be appropriate. So in an array list, a variable length collection class, you might use an array list to keep track of inventory as you store, as your store of special tools, weapons, livestock increases. Those things change, so the list of items needs to be able to change with it. That's where an array list would be appropriate. An enum shares some similarities to an array as it is a fixed length list, but that's where their similarities end. Unlike an array, once you declare the constants of an enum, they cannot be changed. Enums can be referenced in a switch case, such as this example of the main menu class. Well, we're going to show you that example in just a minute. So here is the locations array, and so this relates to the map. And anytime you see brackets like this, even one set of brackets, that's an array. In this case, we have number of rows and number of columns. This represents our matrix, and these are going to be numbered 1 through 5 on each side. So we go a little further down, and you'll be able to see how that map is demonstrated. So here's an example of how to use a basic statement and index to access each element in an array. So you might have noticed earlier we had those loop functions and we had the array declared. So here's how you might travel to each location. So if you travel to location 01, you meet an old wise man in your travels. He asks if you have, and it kind of cuts off on this picture, but he asks if you've heard of kamut, which is an ancient Egyptian grain. Or you find a protein bar, add 3 strength to your taskmasters. So there's different options for each one of these matrices within the array. And it took a while to create this, but it does make it, I think, a little bit more fun, because then you can explore each part of the map and see if it has some hints for you or if there's just nothing there. So here's how to throw and propagate and catch custom runtime errors in your program. This is also known as exception handling. This is very important. The program is designed to expect certain responses from the user. If it doesn't receive that response, or receives a response that's outside of its expectations, the program can crash. So to make it a more smooth experience for the user, we create a function that deals with responses that are not expected. So in this case, you can see, and to do that, you'd use a try catch statement. And so in this case, we've got your do while, and you've got your try catch encased in there. And the try catch is basically just, let's try this. And if something doesn't work, then let's catch exception E, which I've defined in the exception class. And so in using this is how we're able to take care of those exceptions. And let's go back just a second. If you enter an option that's less than 1 or, and this is an or, greater than 5, there's only 5 options on this menu. So a value that's less than or greater than 1 or 5 is going to throw an error. And we'll see that in our demonstration in a minute. Why a character string class should be used versus a byte string class when reading and writing data to a file. The character stream class is more versatile. If you're going to be introducing a project on a global scale, there's different languages out there that are going to need to be able to access that program. So